So today we're going to be tackling this problem. The graph of a quadratic function y equals the f of x is shown in the graph. A. Find the vertex and the axis of symmetry of the parabola, and B. Construct an equation of the function. So, the vertex of a function is the middle point of the function, which is labeled right here. So if we were to find that, we would go 1, 2, 3 spaces to the left and 2 spaces up, putting this point at -3, 2. And that is our vertex. Now the axis of symmetry is when a line cuts through a graph and it folds over on itself and it is symmetrical. So this graph right here, this line, as some people know, an x line through -3, or like say if I were to graph the line x equals 1, this would be that graph. So in this case the axis of symmetry is -3, so the axis of symmetry would be x equals -3. Okay, so now on to part B. Construct an equation for the function. So we see here that the graph is shifted over 3 and up 2. So by that, to move the graph left 3, you have to add 3. Because when it's inside the parentheses, it's opposite of what you're doing. So we're moving negative on the graph, so that means it's positive as a shift. Only in the horizontal plane. Now in the vertical plane, obviously we moved up 2. So this goes over here, outside the parentheses, and is the same sign as it is on the graph, +2. Now, there are no stretch and compressions because the first point is right here, and the next point would be over 1, down 1. So as we can see, that is the base point for any parabola, but in this case the parabola is reflected over the x-axis, which means the negative goes in here rather than inside the parentheses. So this is the final answer for B.